There we go. So for this first part, we need a variable name and a variable symbol. Just this is a review. It's not a hard review, but just so we're on the same page. All right. So milliliters. What's my variable there, Jaden? Milliliters is a unit of what?
Like volume.
There you go. Volume. What is my variable symbol, Jaden?
L.
Variable for volume.
Oh, V.
There you go. V. Kaylee, 35 degrees Celsius. Temperature. Symbol. Variable letter. T. Atmospheres, ATM, Anthony. It's a unit of what?
Measure.
What is it? What's it? It is. No, it is. It is. What is it measuring?
Atmosphere.
Atmospheres is a measure of what?
Oh, pressure.
There you go. Pressure. What is my symbol?
P.
Millimeters of mercury. Preston.
Pressure.
Pressure. Symbol. K. Ellis. Hmm?
Oh, temperature.
It is.
Okay. I mean, T.
There you go. T. It's Kelvin. It's the Kelvin scale. Okay. Jerry. Number 7.
Temperature.
Symbol. Number 8. Sean.
Volume. V.
B. Lavina. There we go. Millimeters of mercury. Dretzy.
Pressure.
Variable.
P.
ATM. Let's see here. David.
Pressure.
Symbol.
P.
Milliliters. Marco.
Volume.
Symbol.
C.
What?
B.
Number 13. We're adding. Number 13, we're adding. Ready? 3.25 MOL. Caden B. What is that variable name?
Wall.
Moles. Or you can put number of moles if you want. Caden L. Variable letter. Hmm?
NOL.
No. That's the abbreviation, but not my variable letter.
Capital N.
No, that's molarity.
I was close.
Marco,
Lowercase n.
that's meters.
Oh, I mean, no, lowercase n. I meant N.
N.
Yeah, that's what I meant to say. Watch it. He whipped that John.
That didn't work very well. Sorry. N. N. That's a big one, guys. We went over that briefly last class, but N is going to be your amount of moles. Okay? Everything else kind of sounds like what it's supposed to be. N is the weird one, okay? So, here we go. Today we're talking about our ideal gas law. So, some background about our ideal gas law. Number one, it's the most useful gas law. And it kind of came about after all of the smaller pieces were found by, in the Kahoot, you saw Boyle, Gay-Lussac, Charles. Those are all scientists that came up with their own kind of individual gas laws. Well, the thing is, if you put all those individual laws together, you get this big one. Okay? This is the only one that really has all of these symbols all at one time, all these variables at one time. The ones that we're going to do next class are going to be the ones kind of broken out, Boyle's Law individually, Gay-Lussac's individually, okay? And you're going to find that they have all of these variables, but not all at one time, okay? So what we're trying to do is give you the big one first and then break it down into the smaller ones, all right? So Pivnert, if you ever heard that before, you'll probably hear me say it again, is in reference to the ideal gas law, all right? And so how many, we'll get to that here in a second. Gas laws are considered ideal instead of real when at 1 atm of pressure and 273 Kelvin is your temperature. All right. Particles have a volume of how much at 1 mole? What's the volume of every gas at 1 mole?
22.4.
22.4 liters. Yes. 22.4 liters. And because of our kinetic molecular theory from last class, KMT, particles have 0 or no intermolecular interactions, which isn't necessarily true, because an intermolecular reaction is a push or a pull on another one. We've learned that most all atoms have some type of force on another molecule, but in this case, we're thinking that they don't. Okay, so because of all this, we can get pressure times volume equals the amount of moles. This R we've got to talk about. T is temperature. Okay, so these multiply together equals all of these multiply together. How many variables do we have? 5 variables. And once again, algebra class, if I give you 5 variables, if the formula has 5 variables, how many must I give you in a word problem for you to solve?
4.
I have to give you 4. So I promise I will always give you 4, whether you see it initially or not. That's kind of a big thing, right? So here we go. The variables are pressure must be in ATM, atmospheres. Volume must be in liters. N must be in the amount of moles. R is a constant. What does a constant mean? That's it. That's the definition of a constant. It doesn't change, right? You've dealt with constants before in math, correct? And that's a good thing for you, all right? So this constant at 1 atm times liters of moles per of Kelvin, your constant is 0.0821. That number isn't just some made-up number. It's actually calculated using some other gas laws and stuff like that, but don't worry where it comes from. Because it's a constant, and this formula has 5 variables, now how many will I give you in a word problem? I'll give you 3 of the 5, because your constant is always going to be the same. Does that make sense? So in these word problems, you should be looking for 3 of the variables, right? This is your ideal gas constant right here, and then temperature always needs to be in Kelvin. Now, that's kind of easy enough. The problem comes when I want you to solve for temperature, right? So I give you everything but temperature, but I want my answer to be in degrees Celsius. So if you put all of these, givens in, and you come out with 500 as a temperature, is that your answer?
No.
That answer is in what? Kelvin. You need to then convert into Celsius. Let's say I want my pressure into kilopascals. Well, after I do all of my givens, what does that pump an answer out in? ATM. I need to then do what? Convert into kilopascals. You see what I'm saying? Because these things are used in this formula, anytime you calculate an answer in this equation, these are the units that it comes out in. Okay? So let's try a few. At the bottom, how many moles? So what variable will we be solving for?
N.
We will be solving for N. I like to write that down right away. Are required to fill a room with a volume of this. There's a volume. Is that a good unit?
Yeah.
Is that a good unit?
Yeah.
So 27,000 goes here. 0.985 ATM. Is that a good unit? That's a unit of what? Pressure, so it goes over here. 0.985. At 25 degrees Celsius, is that a good unit?
No.
It is not. 25 degrees into into Kelvin, you add 273. 8, 9. My constant goes here. 0.0821. My temperature goes right after my constant. Any questions there?
How do you know if it's adding or subtracting?
You need to look at that conversion. All right. So to do this into my calculator all at one time, technically the math tells me I should take 0.0821 times 298. That gets rid of all that. Whatever I do on one side, I need to do the other side. 0.0821 times 298. Right? So to do that in my calculator all at one time, parentheses, 985 times 27,000. In your parentheses, division. Open up another parentheses, 0.0821 times 298. Close your parentheses, and you get that as your answer. Sig figs matter. If I look at all of my measurements here, my constant doesn't count because it's a constant. It has an infinite amount. How many sig figs here? How many here?
2,
How many here?
3.
3. Let's look back. Well, if I look at this constant, or this given, how many do I have?
2.
And we use that in our measurements.
2.
So I should be using 2 sig figs. Right? Well, how do I get that answer into sig figs? There's 1. That 0, I look at there's my second sig fig possibly. I look here, what does that round up to? A 1. So my answer should be 11,000. How many moles of N2? Because that's what I was solving for. Okay, on the back. If you want to rewrite your formula at the top, PV equals nRT, your constant always equals 0.0821. You'll memorize that after a while, but just to get started. So, laughing gas is used by dentists as an anesthetic. If 2.86 moles, is that a good number? A good unit. Gosh, is that a good unit?
Yes.
Yep. So I have 2.86. Right after that is my constant, 0.821. If gas occupies 20 liters, is liters a good unit?
Yes.
Liters is a good unit, 20.0. 23 degrees Celsius, is that a good unit? Nope, we got to add 273 to 23. 296. What am I left out? Pressure, which is a good thing because it says what is the pressure in the tank of the dentist's office. So the easy thing to do here, divide both sides by 20. That takes care of that. That takes care of that. So I put in my calculator the right way. All at one time, 2.86 times 0.0821 times 296. Close your parentheses, division. Divide that by 20. How many sig figs should we be using? Look at all your givens. 2. How many sig figs? What's my answer going to be?
3.5.
ATM. And then you can put N2O as well. Okay. Number 3. Third one. This is where it gets maybe a little bit different. Determine the volume. So what variable will I be solving for? I will be solving for V. Of occupied 2.34 grams of carbon dioxide. Is that a good unit? It is not. What do I need to do? I need to convert to moles, which is 2.34 grams carbon dioxide. And I need to get it into 1 mole of carbon dioxide. What goes down here? The molar mass of, which is what? You all should be calculating that. There's a periodic table over there. What do we get? So 44.01, we'll say. When I take 2.34 divided by 44.01, how many sig figs? 3. So when I plug this number in over here, I should put, yep, 0.053. My constant goes next. Then I run out of numbers. Or do I? STP means what? Standard temperature and pressure. So what is my standard temperature and pressure? Casey?
273.
273 is my temperature. What's my standard pressure? 1 ATM. Did everybody see that? So we do have enough information here. So technically, the algebra says divide both sides to get V by itself. So that's what I'm just showing. But in this case, because we're ones, we just multiply those out. Right? And what is my 1.19? What am I looking for?
Volume of
Liter of carbon dioxide. Okay. Next one. At what temperature? So what variable will I be looking for? Temperature. Right before temperature is my constant. Well, 0.65 moles, is that a good number? Is that a good unit? Sorry.
Yes.
Because we're in moles, 0.654. 2.30 liters, is that good?
Yes.
The pressure is kilopascals, is that a good pressure? It is not. I need to convert, and this, if you missed the other day, this is one of the new conversions. Kilopascals into what unit? I got to get into 1 ATM. Well, how many kilopascals equal 1 ATM? Those cancel out. I'm left with the units I need. So 195 divided by 101.3 equals 1.924. So I should be using 1.92 because of 3 sig figs. Then to get T by itself,
You divide 0.654.
times 0.082. That cancels all of that out. Whatever you do to one side, you do to both sides. 0.654 times 0.0821. Put that all into your calculator the right way. Let me do it over here. There we go. Times 12.30. 0.654 times 0.021. And you get that number. How many sig figs should I be using? 3. So I have what?
46.5.
What is it?
46.5 total.
You're missing something. So the problem is
I got 440.
440, but that's not 3 sig figs. You would need to put it into scientific notation. Oops. To get your right sig fig. So now you have 4.40 times 10 to the second. What temperature? Kelvin.
Why do you need to put into?
To get sig figs right.
Oh.
Because there should be 3. Okay. The last one. Anybody figure it out yet? Good. This one's on you. Who can ever give me the right gas? Come show it to me, and I got 2 airheads for you.